Okay, as we've seen then, the values of the cosine are obtained from values of the sine by shifting the values of the sine to the left. Now we ask the question then, cosine of theta. If theta is a point along this axis, okay, and we don't have a scale on this graph, but the graph will eventually be scaled and theta will be some point along this axis in whatever scale we use. And actually for using theta, the period of the graph is going to be 2 pi. But right now let's just consider theta to be just any number, any point on this graph. Okay, so we want to figure out how to get the value of the cosine of theta. Okay, so and by that then we want to know from what value of the sine do we obtain the cosine of theta. Okay, so the cosine of theta is the sine of what? Well, we can reason this out. To get the cosine value, you have to shift a sine value to the left, quarter of a cycle to the left. But let's just get the left and right straight here. Okay, to get the cosine value, we have to shift the sine value to the left. So the value of the cosine is obtained from a point where? It's going to be a point on the sine graph. Where's that point on the sine graph going to be? Well, that point on the sine graph has to be shifted to the left to give you the value of the cosine. So if you want the value of the cosine here, you'd better grab a value of the sine off to the right. So we say to get the cosine value, you have to shift the sine value to the left. So the value of the cosine is obtained from a point on the sine graph to the right. Now I've got a kind of a picture here. Here's our theta, and here is our cosine graph. We want to get that value, but all we know is the values of the sine function, okay? So, well, here is the value of the cosine function. But if all we know is the values of the sine function, how are we going to figure out just what that is? Well, what we're going to do is we're going to move a quarter of a cycle to the right to get the value of the sine, because that value shifted a quarter cycle to the left gives us the value of the cosine. So that the cosine of theta is the sine of what? Theta plus a quarter cycle. So this distance here is a quarter cycle, the same distance through which we've shifted everything else. So find a good place to write this. A quarter cycle shift to the left, and that's what we see here. There's our quarter cycle shift to the left, so that what is this point here? If this point is theta, then the coordinate of this point, well, from this point we shift a quarter cycle to the left to get theta. So from theta we're going to have to move a quarter cycle to the right to get to this point. So the coordinate of this point is theta plus 1/4 cycle. So we can write this in general then, cosine of theta equals the sine of theta plus a quarter of a cycle. Okay, now if we're in degree measure of angle, and we haven't yet talked too much about labeling these axes and scaling these graphs, but one measure of angle would be degrees. Well, in that case, a quarter cycle is 90 degrees. Another measure of angle, and we've seen it, is radians. We've seen some of the reasons why we use radians. And a quarter of a cycle then is a quarter of the 2 pi radians that makes a complete cycle, which is pi over 2 radians. So whatever our unit of measurement is, we're still going to replace theta by theta plus a quarter of a cycle. Now there's more to it than this, but this is an instance of the general principle. Of course, I could have just quoted this general principle, because it's something everybody who starts, well, maybe I couldn't, because this isn't just addressed to people who are starting a pre-calculus 2 course, but everybody who's had Algebra 1 and Algebra 2, or Algebra 1 and geometry, should probably know this, and anybody who's had Algebra 2 should absolutely, certainly, definitely know this. And the general principle is just that replacing x by x plus h shifts the graph of any function f of x in the horizontal direction through displacement negative h. And again, we see that the sine of theta plus a quarter cycle gives us a value, well, gives us a graph that shifted to the left by a quarter of a cycle. If it was minus a quarter cycle, the graph would be shifted to the right by a quarter of a cycle. And it's a little hard to get our heads around this, because it looks like if we add something to theta, we should be shifting to the right. But that's not what's going on. This says that we're getting our value of this function by looking to the right, and that the value of that function then occurs for a horizontal value to the left.